help the brain become more organized and ready for increasingly complex communication. The surprise, though, came with the next phase, ages 9 to 32. As neural networks become more efficient and specialized, regions of the brain take on clearer, more refined roles. This phase was thought to end when people reach the age of 25, but the new research shows otherwise. Brain efficiency then declines from ages 32 until 66, a period when information does not travel as quickly among different brain regions. In the third phase, from ages 66 to 83, brain health declines as white matter in the central nervous system thins out. This is also the period when dementia often presents itself and high blood pressure can begin to take its toll. Beyond the age of 83, brain health is less predictable. Connections are fewer, and any declines, of course, become more pronounced. There were some limitations to the study, though. The researchers looked at the brains of more than 4,200 subjects from newborns to 90-year-olds. This was a cross-sectional study which did not look at how the brain of one person changes across their lifespan. And joining us now from more is neurologist Dr. Leah Kroll. Dr. Kroll, thanks so much for joining us. As we just mentioned, this study is saying that our brains age within 5 stages, and age span within those stages is pretty vast. What's the significance of this?
Lindsay, we're sort of taking a Taylor Swift approach to brain development where we're looking at the brain taking on sort of eras of organization within itself. And we're really seeing that over time, the brain is constantly remodeling itself, improving itself, fine-tuning its connections. It's always changing. It's always learning. There are certain eras where the brain is more plastic or more able to make those new connections within its different regions relative to other eras.
How will this study potentially help future medical research when it comes to our brain and understanding it?
Well, I think really this comes down to 2 different things. The first is what we just mentioned, which is that the brain is always changing, which means there's always an opportunity for us to intervene to promote better brain health. We've talked a lot on this show, you and I, about the importance of a healthy lifestyle for protecting your brain health as we age. And I think that research like this will only help us better understand the relationship between our lifestyle and medical choices and what our brains can do as we get older. The other thing that's really interesting here, as you mentioned, that adolescent phase of brain development that goes from ages 9 to 32 is longer than we once thought. This also happens to be the years where a lot of mental health problems start to declare themselves. So I think that gives us a new sort of direction in terms of the research on this. What's going on as the brain is maximizing its efficiency and strengthening its connections in these years, that also makes it more vulnerable. And how can we use what we learn from research like that to inform interventions, to treat and maybe even prevent mental illness?
And you just touched on this. I do think, though, that reading this study, many people are going to be surprised to learn that adolescence extends into our mid-30s. Does this mean we do have to rethink the way we see and understand adolescence, or is there now a new meaning that will be ascribed to the word?
I think that really when we're talking in this context, which is the adolescence of neuroscience, that's something different than what we classically think of as adolescence, right? Because what this study is not saying is it's not saying that the brain of a 30-year-old and a 10-year-old is exactly the same. It's more that in those years, the brain is undergoing a general pattern of reorganization and development. But certainly adolescence, as it pertains to our biology and our bodies, and our psychological development, remains the same. It's more just that the brain is still fine-tuning those connections beyond the mid-20s, which is different than what we previously thought.
And so the study didn't take into account differences in sex or psychological changes like menopause. Does this help give us a broader view of how our brains are changing and wired through the course of our lives?
It does. I think one thing we've been learning, and it's really interesting that you mentioned menopause in particular, is that the brain does remodel itself, that it does become sensitive to its environment, whether that's a medical environment, a hormonal environment, a lifestyle environment. We know from research that came out earlier this year, for example, that the brain remodels itself during and after pregnancy, for example. So I think really understanding how the brain is changing over time, kind of applying this new era, if you will, framework towards neuroscience and brain research will really help us better understand how the brain is changing with us as we change with time.
And what are some things that people can do in order to try to make the transition into these different phases less severe?
The number one thing that I always tell people for promoting better brain health is exercise. So it doesn't matter if you're a child or you're in your 90s, exercising will do such good for your brain, both in the short term in terms of maximizing performance and in the long term in terms of protecting your brain health, minimizing that risk for cognitive decline. Beyond exercise, you want to look at a healthy diet. We love the Mediterranean diet in neuroscience. Maximizing your sleep, managing stress well, and really maintaining healthy relationships and a healthy social life throughout your lifetime.
Dr. Leah Kroll, we thank you so much for your time. Really appreciate it.
Thank you.